Well, good morning. My name's Nick Young. I'm a PhD student with the University of Exeter and the European Centre. And my talk is about my PhD research, which is understanding the connections between weather and climate, harmful algal blooms, and human health for the UK. So my focus is on marine harmful algal blooms, and essentially these are oceanic primary production, and they require nutrients, sunlight, and a lack of removal to bloom and grow. But they pose a potential danger to the environment, to wildlife, and also for human health. So how do these harmful algal blooms cause their effects? So they can either be high biomass, so essentially they deplete the oxygen, or have direct impacts on wildlife, can cause blockage of fish gills and mucus production. But also there's low biomass toxins that have their effects through either consumption or exposure in other ways on humans. So harmful algal bloom toxins are natural, they have no taste or smell, and can be toxic in very minute doses and not destroyed by cooking or freezing. And here I've just presented an example from Cornwall, where we had an outbreak of shellfish poisoning from this particular algae, Dinophysis, and toxins within the food chain. So what is the evidence? So this is the first stage of my PhD. I did a systematic review of all the evidence for clinical effects of harmful algal blooms on human health. And essentially, there's very few studies that look at chronic exposure or the chronic effects of acute exposure, and most studies are case series of acute events. So making the connections, what I plan to do is statistical time series modeling, so looking at complex oceanographic models and linking them to monitored biotoxin data, but then also build models with human health in, and then try and look for associations, predictions of occurrence, intensity of blooms, health outcomes, and then go on to incorporate climate projections into that. So the data that I'll be using, I plan to use the Copernicus, EU Copernicus program, looking at open source data of oceanographic models. And here's an example of chlorophyll data that's modeled for the 5th of October, yesterday, across the northwest Atlantic shelf. And I'll be linking these data to biotoxin data. So across the UK, there's a biotoxin monitoring program looking at the levels of phytoplankton, but also toxins within shellfish in aquaculture beds. And you can see there's good coverage across England, Scotland and Ireland. And essentially this monitoring takes place throughout the year, and we're using these data to link to the oceanographic data. And then moving on from that, human health data as well. So I plan to incorporate this into the models. The most likely useful resource will be syndromic surveillance. So across A&E departments, hospitals in the UK, we monitor for gastrointestinal infections, respiratory illness, and other particular syndromes. And just like to thank my supervisors who are listed here, and also Alison Bethel, who helped greatly with the systematic review that I carried out. So any questions?